Hello guys, myself Abhay Singh and I am third year electronic student of DJ Sanvi College of Engineering. So today I am going to demonstrate you an integrator circuit in LT Spice using op-amp OP07. So firstly, what is integrator? So integrator circuit is an electronic circuit which outputs the integral of the input signal over certain frequency ranges, and also it does some mathematical operations such as integration. So firstly we will head towards some calculation and then we will do our simulation in LTSpice. So here are some formulas. So such as I have taken FA as 1 kilohertz and FB as 10 times of FA, means 10 kilohertz, and CF as 10 nanofarads, and by putting these values in FA and FB we have calculated the RF and R1, which is the feedback resistor and input resistor, as you can see in the circuit. Okay, so I have come in our LTSpice workspace. Now I will go in file and open the new schematic file, and in our new schematic we will made our integrator. Okay, so firstly we will take some components as we require. So I will go in component section from here and I will take OP07. I will type OP07 and press the enter. So here I have get my OP07. I will place it here. Then next I will take some resistors. Okay, so I will take the resistor from here and I will just rotate it by pressing Ctrl R. So I have placed one resistor here, another here. That's it. I will next I will take one capacitor. I will again rotate it by pressing Ctrl R and I will place it somewhere here. Okay, so next I am going to take voltage source. Okay, so I am going to take voltage source from component and I will write volt and press the enter button. Next I will place one voltage source here, one here, and another one is here. Then I will place some grounds, 1, 2 and 3. Now I will make the connections and then simulate it. So I have connected R2 resistor with OP07 non-inverting terminal, sorry, inverting terminal, non-inverting terminal with ground here, and voltage source with input resistor, and then voltage source with ground, and this feedback resistor with op-amps, and capacitor with resistor. And next this is our output where we are going to take the output. Then this resistor is connected to the output terminal. Okay, so next I am going to connect this voltage source among them. Next I am going to place some label nets. So Vout at the output terminal like this. Then next I am going to place VCC, one VCC here and another one is here. Next I am going to place the label net of VEE, one is here and another one is here. Yeah, so yeah, our circuit is completed. Now I am going to assign the values to each component. This resistor I am going to keep as 15.8 kilo ohms, and this resistor is 1.58 kilo ohms. This capacitor has 0.01 microfarad. Next I am going to give the voltage source as 15 volt plus 15 volt and another one as minus 15 volt. Next I am going to give the values to the input voltage source. As I have pressed on right click on this voltage source, I have gone a pop-up window like this. So I will click advance on it, and as I click on advance, we have pop up this window, and here is many types of input which we can give to our circuit. So right now I'm going to give the sine input. Okay, so I'm going to give the sine input and keep the amplitude as 1. Okay, so next I'm going to set the DC offset as 0 and amplitude as 1 and frequency as 1 kilohertz. Okay, as I have set the all values, I will press the OK button here. Next, our computer is all set. We can simulate it, we can run it. So we will just press the run button here, and we will give the stop time as 0.005 and press the enter. So you can see I have got my waveform screen where we are going to see our waveform plot. So by using this red button, this probe button, we will take our input waveform on screen, this, and the output waveform like this. So you can see I have got my input waveform and output waveform. Okay, so our input is this green button, green line, green waveform is our input, and this blue or pink button is pink waveform is our output waveform. So here I have given my input as sine input, and at the output we can see inverse cosine at the at our output. Okay, now we will head ahead to our circuit, and we will give square wave as the input and see the triangular wave as on the output. So for that we doesn't have to make the whole circuit again, we have to just change the input here from sine to square. So just press the right, so just click the right button on the voltage source, and from sine voltage source just click on the pulse means square voltage source. Okay, now if we give the square voltage source, we have to change these parameters, such as I will keep this P initial as -1, next V on as 1, and delay as 0, T delay, and T rise as 0.001 micro, and T fall as 0.001 micro. Next T on as 0.05 milli, milli not mega, and next as T period as 0.1 milli. So we have set the following parameters. Now we will press the OK button here, and as I press the OK button, now we are going to simulate it, the pulse wave, and going to see the triangular wave on the output. So as you can see, our output, we can see we have given as the pulse as the input, this one pulse as the input, and having the triangular wave on the output. So to view it clearly, just zoom on it and you can see it more clear. Okay, so as I have given here pulse as input and taken the triangular wave as output, now we will do just opposite of it. We will give the triangular wave as the input and see this sine wave on the output. So just minimize it and maximize this circuit window, circuit tab. Next, just here only we have to do some small transitions. Just firstly click the right the voltage source, then we will see this window, then instead of pulse we will keep the pulse only. Just we will just take these parameters different. such as initial will be -1 only, t1 will be -1 only, and delay will be 0. But we will change the t rise and t fall time. T rise will be 0.05 milli, and t fall is also 0.05 milli. I forgot to take the point here. Yeah, now it's right. And t1 will be 0 and t period will be 0.1 milli. Next press the OK button here and then simulate this. Yeah, so you can see here our input and our output. Our input is triangular wave, as you can see, and output is sine wave. I will zoom it for the better interaction. Yeah, I hope you can able to see it more clearly. Yes. So it is now 1.2 volt peak to peak. Okay, so as we have seen this, and now we are going to see the frequency response and phase response of the circuit. For that we are going to make the small changes in voltage source once again. So for it we will just press the none over here, and during the run time in the edit simulation command we will go to AC analysis, and in AC analysis type of switch should be decade, and number of points per decade you're going to keep as 500, start frequency as 1 and stop frequency as 100k, and press the OK button. Okay, now I'm going to run it, and as you can see it is our frequency response. So here I am going to see a DC line, as we have given the input as none. We have doesn't provided any input, so just maximize this, and we will remove this, delete this trace. We will click on this trace, that trace will be deleted. Next we are going to delete the phase trace also. So we are going to see only our frequency, which is acting as a low pass filter from 20 dB to. Okay, next we are going to see, as we have seen now the frequency response, likewise we will see the phase response. So just I will run this circuit again, simulate it again, and as I have taken the output, this only waveform, we will just going to see the output only, not the input waveform. So just maximize it, and right click over here on this y-axis and just click on the don't plot the magnitude. As I have pressed don't plot the magnitude, this is our the phase response of an practical integrator. Okay, this is our phase response of a practical integrator. So thank you very much guys. I have shown you integrator using OP07 on FD Spice. Thank you very much.